Hello everyone, hello students, welcome to Crack Academy. My name is Antash Manocha and today we are going to start with the next topic of your quadratic equation, and that is nature of roots. Guys, let's have a quick recap of the things that we have covered up in the last lecture. In the first lecture of the quadratic equation, we had revised the concepts of polynomials, remainder theorem, factor theorem, and after that, what? The relation between roots and coefficients. We have seen number of examples where we need to apply the sum of roots, product of roots, difference of roots. And lastly, we had covered what? The Newton's theorem. And we have seen the examples where we need that particular fundamental to solve the question very easily. Okay, so guys, in this lecture we are going to start with the nature of root of any particular quadratic equation. Okay guys, so let's move further. Yes, so the topic is very similar to your 10th level. In 10th standard we also had this topic, that is nature of root. We all of us have the idea, like for any particular quadratic equation, ax square plus bx plus c, where a is not equal to 0, a is the coefficient of x square, b is the coefficient of x, and c is the constant term or the coefficient of x bar 0. The roots are alpha and beta, and the discriminant is b square minus 4ac. Now, if the discriminant, what is discriminant? Yes, this b square minus 4ac. It will discriminate the category of roots. That is why it is known as discriminant. Now, if discriminant is positive, then roots are said to be real as well as distinct. Real and distinct. Hurry up, please note it down. Okay, so in the next case, when discriminant is what? Equals to 0. So yes, in this case roots are said to be real as well as equal. Very easy. And the next case, when the discriminant is said to be negative, in that case the roots are labeled as non-real. Okay guys, we have a chapter in which we'll categorize these non-real roots in +1. Okay, but at present we'll just simply say when d is negative, roots are said to be non-real. So these are the three varieties. We'll have some more also. Okay, but let's practice these three types of nature of roots in some questions. Okay, let's have the first very basic question, guys. It simply says, tell me the values of k for which this particular quadratic equation will have what? Real and equal roots. This particular quadratic is having what? Real and equal roots. So guys, the quadratic is x square plus kx plus 9 is equals to 0. Now this is having what? Real and equal roots. So what was the condition? The discriminant is supposed to be 0. So what is discriminant? That is b square minus 4ac, that should be 0. If you check what is b, b is k minus 4a and c, that is supposed to be 0. So from here k square comes out to be 36, and the value of k would be plus or minus 6. So your answer is plus minus 6. Okay, it could be plus 6 as well as minus 6. Very easy, we have applied d as 0 and get the values of k. Next, let's have one more question of similar type. Very easy. If both the roots of this particular quadratic equation, now this time the unknown thing is lambda. As you can see, this unknown thing, earlier it was k, here it is lambda. Okay. If the roots are non-real, now non-real roots means what? The discriminant is supposed to be less than 0. Then what could be the possible value or set of values of lambda? That is the demand of this question. So guys, what to do? Yes, both the roots are non-real. So what will I do? Yes, D is supposed to be less than 0. That is the basic idea. What is D? That is B square minus 4AC. That has to be less than 0. And what is B? Instead of B, yes, we have minus lambda. Yes. Instead of B, yes, we have minus lambda whole square minus 4. A is 1. C is 4. So guys, here lambda square minus 16 is what? Less than 0. Now, how will you solve this inequality? Earlier it was just equality in the first question. Now we have one inequality, lambda square minus 16 less than 0. Okay, yes, it seems like a quadratic inequality is there. So for that quadratic inequality, we need to figure out the values of lambda for which this is justified. So which method we should use? Yes, the quadratic inequality, rational inequality. Yes, we'll use our favorite Brahmastra, that is wavy curve method. Okay, so first check right hand side is 0. Yes. Next, we need to make sure the left hand side is written as linear factors. So lambda square minus 16 can be written as lambda minus 4 and lambda plus 4. All right. Now, third check of wavy curve method, the coefficient of lambda should be positive. That is also there. Now, fourth thing, we'll plot a number line and mark the zeros. The 0 of this bracket is minus 4. The 0 first one is at 4. Thereafter, we'll do the wave dance, positive, negative and positive. And what was the demand? This group is supposed to be less than 0. Less than 0 means negative answers. Negative answers are presented here. Only negative is there. So guys, lambda belongs to what? Minus 4 to 4. Okay. So which option should we mark? The first one? No. The second one? No. The third one, yes, minus 4 to 4, but square bracket, no. So fourth, none of these is there, because the difference is that the exact answer is having only simple open interval, simple brackets are there. C option is saying square bracket, that means they are going for the closed interval. Okay. So if the roots are non-real, the lambda belongs to minus 4 to 4. Let's go to the next case. Yes, please. Let's have the next wording in nature of root, next result, next category, the fourth one. So I'm continuing with the same topic, nature of root. Now observe, everything, most of the things are related with the discriminant. That is why it is known as discriminant. D positive, roots real and unequal. D negative, roots non-real. D zero, roots real and equal. Now, if D is a perfect square, guys, what is perfect square? One square, 1, 4, 9, 16, 25, 36, 100. These are the numbers which we can say they are perfect square. The square of any natural number, okay, or also 0. They are perfect square. So if discriminant is what? A perfect square. Let me write the roots. What are the roots of any quadratic equation? Yes, how do we write? What is the quadratic formula? Minus b plus minus root d by 2a. So guys, they are saying if the quantity within the under root is a perfect square, so that root and that square will be adjusted. So in this case, then the roots of this particular quadratic equation, are rational. I repeat the wording, rational. Roots are rational, provided the coefficients are rational. Provided the coefficients are rational. Okay. Otherwise, the roots would be irrational. Now, what do you mean by otherwise? Otherwise means if coefficients are not rational. This is the condition. If D is not a perfect square, in those cases, if you don't follow these things, if D is not a perfect square, if coefficients are not rational, then roots may be irrational. Otherwise, if these two conditions are there, what are those two conditions? If D is a perfect square and the coefficients are rational, then finally we will be having roots as what? Rational. Otherwise, it is irrational. Okay. Let's say, I'll give you a quick example on this. Let's say if I say like solve this equation, x square minus 6x plus 2 equals to 0. Seems like coefficients are rational. Okay, the first coefficient is 1, second coefficient is minus 6, third coefficient is 2. Now, let's see what is the discriminant of this particular quadratic equation. Guys, discriminant is b square minus 4ac. What is b square minus 4ac? That is 36 minus 4 into 2. Okay, so guys, in this case, this comes out to be 36 minus 8. So, what is 36 minus 8? It comes out to be 28. Is 28 a rational one? 28 a rational one? No. Is 28 a perfect square? No, 28 is not a perfect square. 25 is a perfect square. Next is 36. So guys, if you figure out the roots of this equation, so they will not be what? The rational. Alright. So D will decide. If D is not a perfect square, roots are what? If D is not a perfect square, roots are irrational. Okay, if D is a perfect square, then roots would be what? Rational, provided coefficients are rational one. Okay. Now let's have one more case, one more example. If I say solve this particular quadratic equation, x square minus 4x plus 3. Now, if I wish to solve this particular equation, but before that, if I figure out the discriminant, D is b square minus 4ac. So guys, this discriminant comes out to be 16 minus 12, that is 4. So 4 is a clear-cut perfect square. So 4 is a perfect square, it is a square of 2. So in this case, if you figure out the roots of this particular equation, because the coefficients are rational, D is perfect square, so roots of this equation would be a rational one. Why so? Let's see. The roots comes out to be minus b minus minus 4 plus minus under root d by 2. So check, this comes out to be 4 plus minus 2 by 2. So one derivative is 4 plus 2 by 2, second is 4 minus 2 by 2. Alright, roots are, D is a perfect square, coefficients are rational. Okay, so roots are rational. D is not a perfect square. If you figure out the roots, it would be 6 plus minus root 28 by 2. Seems like the irrational. Okay. So please make a note of this property, this point, and now we are going to discuss some question based on this. Let's have a very good question. Observe the variety of the question. The question is having two statements. One is known as assertion, next is known as the reason. Let's have the variety based on assertion and reason. In JEE Mains and in JEE Advanced, they used to ask question based on this particular type, the assertion and reasoning statement. So what is the basic approach in this particular type of question? So guys, in assertion and reason statement, we need to check the individual validity of the two statements. If both of them are true, thereafter we'll check some connection, whether the reason is justifying the assertion properly or not. Okay, so if I simply look at the statements, the first one seems to be a very complicated one. The equation, this coefficients are very high, 2009, 2008, has rational roots. Okay, do we need to check the discriminant? Do we need to solve this particular quadratic equation? Wait, coefficient seems to be rational. Okay, let's look at the next statement. The equation ax square plus bx plus c has rational roots. They are just declaring this is having what? The rational roots. If and only if, what do you mean by if and only if? That means only in under this condition. If and only if, IFF means if and only if. This b square minus 4ac, what is b square minus 4ac? That is discriminant. Okay, if discriminant is a, yes, perfect square. Alright. So guys, first statement needs some calculation, but second statement is a factual thing. So let's check the second statement first. If second statement is authentic, thereafter we'll move to the first one, and then we'll see if both of them are true, then we'll see the connection between them. All right. Now, please comment about the reason one. If the equation has rational roots, D, if and only if, sorry, the equation has rational roots if and only if D is a perfect square. If D is a perfect square, only in that case the equation will have rational roots. Doesn't seem nice, no? Because from the previous point we have a note that the coefficient are supposed to be the rational one. They are not declaring that the coefficient A, B, C are whether they are rational or not. So it seems like the insufficient information is there. So guys, the reason statement is clear cut. No, this is not true. So do we need to check the assertion first? But wait, let's see the variety. Let's see the option. First statement, both statements are true. So our reason is not true. So first can't be the right one. Second is both statements are true, but reason is not explaining. But again, reason is not true. So this would not be the right one. The third statement, assertion is true. Okay, assertion may or may not be true. We have not checked that. Okay, but reason is false. This is fine. All right. Fourth, assertion is false. Okay, we have not checked assertion, but reason is true. This is not true, yeah. So this would not be the right one. So by eliminating, we get the right option, that is option C. So we don't need to find the roots. We don't need to figure out the discriminant, whether it is a perfect square or not. Just go and mark option C, because only one option is there which is saying the reason is false, and that is a fact. Okay, because A, B, C are not rational. They are not providing A, B, C are rational, whether they are rational or not. Okay, let's move to the next case, guys. Next, now we have the fifth point of nature of root. What is it? It simply says if alpha plus root beta, if alpha plus root beta be an irrational roots of any particular quadratic equation, all right, then alpha minus root beta would also be there in the same, would also be a root of the same equation. Once again, writing information like provided all coefficients are rational, provided all the coefficients are rational. Okay, now it is saying if alpha plus root beta is a root, then alpha minus root beta is also a root of that particular quadratic equation, provided the coefficients are rational. Guys, let's see this. If I simply say solve this particular quadratic equation, it's like the previous one. X square minus 4x plus 1 equals to 0. Let me solve this particular equation. What are the coefficients? 1, minus 4, 1. Coefficients are rational? Yes. Let us find the roots. Let us find the roots. What are the roots of this equation? So I am directly using the quadratic formula. What are the roots? Roots are minus b, yes, plus minus b square minus 4a and c by 2. Check the calculation. So it comes out to be 4 plus minus root 12 is what? Root 12 is there, yes, upon 2. What is root 12? So guys, this is 4 plus minus. Under root 12 can be written as 4, under root of 4 into 3, and under root of 4 into 3 can be written as 2 into root 3 by 2. So finally roots comes out to be 2 plus root 3 and 2 minus root 3. As you can see, if one root is of the type alpha plus root beta, then the other one would be alpha minus root beta, provided the coefficients are what? Coefficients are what? Rational. If one root is of the type p plus, if one root is of the type p plus root q, then other one would be of the type p minus root q. You can just change the label alpha plus root beta, alpha minus root beta, p plus root q, p minus root q. Okay. Condition, coefficient must be the rational one. Let's have a very quick question on this particular variety. Yes, please. If one root of the quadratic equation with rational coefficients, if one root of the quadratic equation, yes, the condition is there with the rational coefficient. So that is a win-win situation. Is 2 plus root 3, just like the previous one, that example that we had. Then the other one would be, guys, coefficients are rational. One root is 2 plus root 3. The other one would be, yes, 2 minus root 3. It is exact opposite pair of that. 2 plus root 3, 2 minus root 3. So which option is there? Yes, option C is there. Okay, that's a very easy one. Now let's proceed further. Let's say the next one. Yeah, it says the quadratic equation having rational coefficients. The quadratic equation having rational coefficients whose one root is, yes, they are providing one root as 1 by 2 plus root 5. The one root is 1 by 2 plus root 5. Then they are saying, don't give me the other root. They are saying, give me that quadratic equation. Okay, hold on. We'll find out that quadratic equation, but that quadratic equation is having rational coefficient. That is a win-win situation. One root is 1 by 2 plus root 5. Okay, one root is 1 by 2 plus root 5. Guys, if I just simply observe this number 1 by 2 plus root 5, it seems like I need to do what? A sort of rationalization. Okay, I'll go for a rationalization just to simplify this thing. So this 1 by 2 plus root 5, if I rationalize this thing, I'll have 2 minus root 5, I'll multiply it with 2 minus root 5, 2 minus root 5. So what will I get? Yes, 2 minus root 5 upon, yes, it is 2 square minus root 5 square. So finally this is 2 minus root 5 upon 4 minus 5. So this is 4 minus 5 is minus 1, and that minus 1 is adjusted with the numerator, so it comes out to be minus 2 plus root 5. Okay, now I am reading the statement once again. I need to form a quadratic equation, one thing, whose one root is, don't read this one, whose one root is minus 2 plus root 5. What is alpha? Alpha plus root beta. What is alpha? Alpha is minus 2. What is beta? Beta is 5. Then the other root is, one root is 2 plus root minus 2 plus root 5. So other root, that would be, yes, with the previous property, it has to be minus 2 minus root 5. Very good. Why so? Because next root should be alpha minus root beta na. Okay, it has to be alpha minus root beta. Alpha is minus 2, beta is 5. So alpha minus root beta is minus 2 minus root 5. Okay, so we know the two roots. Now we can easily form that quadratic equation. How will you form a quadratic equation if the two roots are there? Yes, we can simply use the previous fact that x square minus sum of roots to be written here into x plus the product of roots to be written here, that to be equated with 0. So it comes out to be, yes, x square minus, guys, what is the sum of the two roots? Yes, minus 2 plus root 5 minus 2 minus root 5. The sum comes out to be, yes, minus 4. And what is the product? Hurry up. Minus 2 plus root 5 into minus 2 minus root 5. What would be the product? Yes, a square minus b square. So this comes out to be 4 minus 5. That is simply minus 1. So finally a quadratic equation comes out to be x square plus 4x minus 1. X square plus 4x minus 1. That seems to be your option A of the given data. Okay. Don't get confused with 1 by 2 plus root 5. First, you need to rewrite your root in the form of alpha plus root beta, for which we have used the rationalization technique. If alpha plus root beta is there, then alpha minus root beta must be there as a secondary root because the coefficients are rational. Okay. So let's move further with the next. Okay. So the next point in this case is what? If A, B, C are real, A, B, C are the coefficients. Okay. If A, B, C are real and D is what? A negative value. If A, B, C are real and D is what? A negative value. Then read this further statement please. Then the roots of the quadratic equation. Then the roots of the quadratic equation exist in conjugate pair. Exist in conjugate pair. Hold on, I'll tell you what is this conjugate pair. That is, roots are p plus root q. What are the pairs? P plus iota q and p minus iota q, where I is what? Under root of minus 1. Guys, for the time being, don't get confused with what is this I. I'll tell you. This I is what? Under root of minus 1, and this is known as iota. We'll have a chapter in which we'll discuss why it is there, how will we utilize this thing. Okay, but as of now, don't worry. Now, if I say what is iota? Iota is under root of minus 1. What about iota square? It is minus 1. Okay, just hold on. Iota square is what? Minus 1. Now, they are simply saying if one root is of the type p plus iota q. I'll not read this as iota I'll read this as iota. Okay, everybody. What is iota? Under root of minus 1. If one root is p plus iota q, then the other one would be p minus iota q. Other one would be p minus iota q, provided coefficients are real. Please make a note of this. Then I'll tell you what is this I, how will we use this. Okay, with one example. Hurry up, please make a note. So guys, once again I am repeating the thing. Don't get confused with the term iota or under root of minus 1. It is very simple. Don't get confused. Okay, I'll give you a very simple example where we are going to use this. Okay, don't worry. But please make a note of the simple point. And what is that point? If coefficients are real, and D is negative. What is D? D is discriminant, is negative. So guys, if D is negative, the roots are non-real. So in simple wording, if coefficients are real but roots seems to be non-real, in that case the roots exist in what? In a combo, and that combo is what? Conjugate pair. The first one is p plus iota q and the second one is p minus iota q. If first root is p plus iota q, second is p minus iota q. Say for example, if the first root is 2 plus 3 iota, the second has to be 2 minus 3 iota. Okay. Now, we are going to understand the fact related with iota with one very basic, very simple example. Let's have that, guys. Please understand. It says find the roots of this particular quadratic equation. Find the roots of this particular quadratic equation. Simple question. Now, before we proceed further, let's calculate the discriminant. And also, please note the coefficients. X square is having coefficient as 1, x is having coefficient as minus 4, constant term is the 30. That is also a real number. Now, let's check the discriminant. What is the discriminant here? B square, that is minus 4 square, minus 4 A and C. Now, it comes out to be 16 minus 13 4s are 52. So, guys, 16 minus 52, it is minus 36. All okay? So guys, here discriminant is clear cut a negative number. So roots are non-real. Now let me draft those roots. Okay. Now how will I write those roots, please? So the roots are to be written as minus b plus minus root d by 2a. So guys, it comes out to be minus of minus 4 plus minus root of minus 36 by 2 into 1. Okay. Now, there is one more thing. In the previous discussion, I have declared one quantity, and that is what? Under root of minus 1. Under root of minus 1 is to be labeled as iota. Under root of minus 1 is to be labeled as iota. So, what about under root of minus 36? So, under root of minus 36 is to be labeled as under root of minus 1 into under root of 36. So, guys, this is under root of minus 1 multiplied with under root of 36. So this person, this segment is what? Under root of minus 1. This is what? Iota. And the next one is the real thing, that is under root of 36, that is 6. So finally this comes out to be 6 times I or iota. Okay. So now here I am representing this under root of minus 36 with what? 6 iota. So guys, my roots comes out to be 4 plus minus 6 iota by 2. Just divide it with 2. So your roots comes out to be 2 plus 3 iota, and the next one is 2 minus 3 iota. Don't get confused with this term iota. Just observe if roots are non-real and coefficients are real, then roots exist in this combo. Just like the previous point, if coefficients are rational and roots are irrational, then they appear in alpha plus root beta and alpha minus root beta. Similar to that, this the point, if roots are non-real, coefficients are real, then roots exist in p plus iota q and p minus iota q. Here p is 2, q is 3. Okay, that's it. That is the use. Now let's move further. Yes, let's have a very simple question of the same point. If one root of the quadratic equation with real coefficient, please make a check, coefficients are real. One root is 3 plus 3 minus 4 iota. Coefficients are real. One root is 3 minus 4 iota. 4 iota. That means roots are non-real. That is why one root is 3 minus 4 iota. Where iota is what? Under root of minus 1. Then they are talking about sum of its roots. Okay. So guys, if one root is 3 minus 4 iota, what about the other root? It would be 3 plus 4 iota, because they exist in what? A pair. If one is p plus iota q, then other one has to be p minus iota q. If one is p minus iota q, then other has to be p plus iota q. That's why if 3 minus 4 iota is there, then the next one would be 3 plus 4 iota. So the roots of our given quadratic equation would be, yes, 3 minus 4 iota and 3 plus 4 iota. And what is the demand? Sum. What is the sum of roots? Yes, the sum of roots would be, just add them, 3 minus 4 iota plus 3 plus 4 iota. Simply adding them, it will be what? Directly 6. So option B is the right one. Okay, very easy one. Now let's proceed further. Let's see the next case. Yes, thereafter we have the concept of cubic equation. So far we have discussed relation between roots and coefficients, and today in this lecture we have covered what? Nature of roots, the different variety related with the discriminant. Now we are going to study some concepts related to what? A cubic equation. Now what are cubic equations and what kind of relations are there in between the roots of cubic equation and its coefficients? Now let's understand this thing. Okay. So first let's have this particular cubic equation, guys. Yes, it is given as ax cube plus bx square plus cx plus d as what? Equated with 0. Okay, where a is what? Not equal to 0. The left hand side is what? A cubic polynomial, and equated with 0 is what? A cubic equation. Okay, and a is what? Not equal to 0. Now let me declare the roots of this equation as what? Alpha, beta and gamma. Cubic at max can have 3 roots. I am labeling those roots as alpha, beta and gamma. Okay, so now the first point, just like in your quadratic equation we had the sum of roots as minus b by a, product of roots as c by a, and difference, absolute difference of roots as root d by mod a. So in case of cubic we have 3 results. The first one is labeled as, yes, the first one is labeled as what? S1. Observe what is S1. S1 is simply the sum of all the 3 roots, alpha plus beta plus gamma. I repeat, alpha plus beta plus gamma. It is simply your minus b by, just like you had this alpha plus beta as minus b by in quadratic. Okay, if you simply add the 3 roots individually and the sum comes out to be minus b by a. The next one, S2. S2, as you can see, it is S2. S2 has a different meaning. Okay, S2 means there are 3 roots. One is alpha, other one is beta, other one is, third one is gamma. S2 means take the sum of the roots. Better to say, take the sum of product of roots, but product taken in pair, product taken in 2 times. So there are 3 quantities, alpha, beta, gamma. One is alpha into beta, one combo, beta into gamma, second combo, alpha into gamma, third combo. There could be 3 possibilities. The 3 persons named as alpha, beta, gamma. If I want you to add them pairwise, okay. So what could be the possible pairings? Alpha and beta, alpha and gamma, and beta and gamma. That's it. So possible pairings are written here. alpha beta plus beta gamma plus gamma alpha. So what is it? It comes out to be yes, C by A. All right. So guys, please note what is S1? S1 is what? Minus times coefficient of x square upon coefficient of x cube. Coefficient of x square, coefficient of x cube minus 10. Okay, what is S2? If you take the combo 2 times and then add the roots, so it comes out to be what? C by A. What is C here? It is coefficient of x power 1 upon coefficient of x cube. What is coefficient of x power 1? C. Here I am not writing the minus sign, okay. And the last case, what is the last case? You can simply write this as S3. Why S3 is here? Okay, basically there are three quantities. I am taking the product of all of three, so that is why it is written as S3. Or simply you can write T. T means the product. So alpha, beta, gamma taken all at a time. So it comes out to be what? Minus D by A. Minus D by A. So how will you identify this minus D by A? Let's see. Minus times. What is D? D is what? Coefficient of x power 0 upon coefficient of x power 3. Please observe something. In each of the case, the denominator is always coefficient of x3, that is A. And in each of the numerator part, the if S1 is there, so 3 minus 1 x2, that means the coefficient of x square is there. If S2 is written here, then 3 minus 2, that means what? 1, coefficient of x power 1 is here. And if it is S3, so 3 minus 3, coefficient of x power 0. Why I am subtracting everything from 3? Because it's a cubic one. Okay. And where you will use the minus sign or plus sign? If it is odd suffix minus, even suffix plus, odd suffix minus. So we'll understand this thing later on. Just I'm building up the base for the next thing. Okay. So what is it? Coefficient of x cube in the denominator. And what about the numerator? Here if it is 2, so coefficient of 3 minus 2, x power 3 minus 2. Here if it is 3, so coefficient of x power 3 minus 3 is there. And how will you decide plus minus? Based on the suffix even or odd. Okay, whether it is even, when it is even, it is plus, when it is odd, introduce a minus sign. That's it. Now, let's apply these things in some questions. Let's have the first one, please. Hurry up, very basic question, please. Everybody try. If 1, 2 and 3, everybody read this question. If 1, 2 and 3 are the roots of x cube plus ax square plus bx plus c equals to 0. If 1, 2 and 3 are the roots of x cube plus ax square plus bx plus c equals to 0, then which of the following option is right? Then which of the following option is right? Okay, now let's see. Guys, 1, 2 and 3 are the roots. What is A? The coefficient of x square. What is B this time? Coefficient of x power 1. What is C? The coefficient of x power 0. So first thing, I'll write the S1. Guys, what do you mean by S1? S1 is simply sum of roots taken one at a time. Okay. Now I'll write what? S2. Guys, what is S2? Sum of product of roots taken 2 at a time. 1, 2 and 3. So first is 1 into 2 plus 2 into 3 plus 3 into 1. Sound similar? Alpha beta, beta gamma, alpha gamma. Okay. Now I'll write what? S3. What do you mean by S3? The three roots make a single product. Product of root taken 3 at a time. Alright. Now let me calculate these things first. Okay. So what is the number here? 1 plus 2 plus 3. It comes out to be yes, 6. What is the number here? 2 plus 6 plus 3. 2 plus 6 plus 3. Yes, it is 11. What is the number here? It comes out to be 6. Done? Okay. Now let's recall the previous fact. What was S1? See, this is at this moment I am just writing the roots. what is the relation between roots and coefficient, because the question is demanding that. They are talking about a, b and c. A, b, c are the coefficient. Leading coefficient is what? 1. Okay, so now what will I do? Yes, I'll apply the relation between roots and the coefficients. What is S1? Guys, let's recall S1. Do we need to introduce a minus sign or plus sign? Yes, minus sign, because it is S1. 1 means odd. Okay, so minus sign is there. And what is there in numerator? And what is there in denominator? Yes, in numerator it will be the coefficient of x power 3 minus 1. Please recall, coefficient of x power 3 minus 1, that is 2. So what is the coefficient of x power 2? That is a. And upon denominator, coefficient of x cube, that is simply your 1. All right. Now, what is this 11? 11 is what? S2. S2 means sum of roots, sum of product of root taken 2 at a time. So in this case, I'll go for a plus 1. Okay, I'll not introduce any negative. Okay, next is, yes, what about the numerator? So in numerator, when it is S2, it has to be the coefficient of x power 3 minus 2. What is the coefficient of x power 3 minus 2? That means coefficient of x power 1. That is what? B is there. And what about denominator? It has to be simply 1, coefficient of x cube. And what about S3? So while writing the S3, I'll introduce a minus sign because 3 is odd. Okay, and in numerator, it has to be what? Coefficient of x power 3 minus 3. That is what? C upon 1. So with this green, blue and black data, you can easily get the values of A. What is the value of A? Minus 6. What is the value of B? 11. What is the value of C? Minus 6. So A is minus 6, B is 11, C is minus 6. Seems like option B is the right one. Easy. So this is how we are going to use the connection between the relation between the roots and coefficients of a cubic one. Okay. Yes. Let's go for the next one. Guys, the next is we'll understand the same thing with reference to a biquadratic equation. Now, what is biquadratic equation? Guys, biquadratic equation is one in which the degree is, highest degree is 4. Okay, highest degree is what? 4. So as you can see in this particular case, the left hand side is a 4-degree polynomial, biquadratic polynomial. Equated with 0, it comes out to be biquadratic equation. It comes out to be the biquadratic equation. Okay. Now, let me label the roots as x1, x2, x3, x4. Now this time I am using a different notation. What is that? x1, x2, x3, x4. I am not using alpha, beta, gamma. I am using some different notation. The roots are labeled as x1, x2, x3, x4. Max it can have 4 roots. Okay. So what is the first conclusion? Wait. First one is, please observe this part, S1. See, the notation is same that we have learned in your cubic. What is S1? S1 has to be, because it is 1, ignore this middle part for the timing. Please ignore this middle part. I'll explain that one later on. What is S1? S1 is sum of roots taken 1 at a time. So it is 1 here. So it has to be minus sign here. Okay. So with this minus sign, what is this? Yes, it is negative of coefficient of x power. Highest degree is 4 now, and it is 1. So it is 4 minus 1 upon coefficient of x power 4. Please check this. Okay, easily coordinating with the previous segment, cubic. It is 1 here, S1. It has to be minus coefficient of x power 4 minus 1. What is 4 minus 1? That is 3. So what is coefficient of x3? That is B upon coefficient of x4, that is A. As you can see, it is here. All right. Let's see the next one. Please ignore this middle part. I'll explain that later on. What is S2? What is S2? If it is 2, so it has to be the positive 1. I'll not introduce any negative at my own. Okay. So it is plus coefficient of x power 4 minus 2. The leading coefficient is 4 and I'll subtract 2 because it is S2. And denominator, it is coefficient of x power 4 only. So as you can see, it is here. What is coefficient of x power 4 minus 2? Coefficient of x square. Coefficient of x square is C upon coefficient of x power 4 is a. The next one, what is it? S3. Now what about S3 guys? If it is 3, I'll apply a minus sign. Then in numerator it has to be coefficient of x power 4 minus this number, that is 3, upon coefficient of x power 4. Okay, check what is coefficient of x power 4 minus 3, that is coefficient of x power 1, that is d, and upon it is a, minus d by a. Let's check the last result. What about this S4? S4 is what? Because it is 4, I'll not introduce a minus sign at my own, it will go as it is. So numerator it is coefficient of x raised to power 4 minus 4, and denominator coefficient of x power 4. Please check the data. What is coefficient of x power 4 minus 4? That is x power 0, constant term, that is e, and denominator it has to be what? A. So are you clear with the red data? It is completely matching with the previous profile with the cubic equation that we learned. Okay, now I'll tell you what about this middle segment. Now read with me. What is this S1? S1 is sum of roots taken one at a time. So roots are x1, x2, x3, x4. So x1 plus x2 plus x3 plus x4. Don't worry, you will not you will not need this blue data at present. You will need this data later on. Okay, so I'm just writing what is this sigma part. What is this sigma? Sigma means take x1, x2, x3, x4 individually and then add them. Next, what is this sigma of x1, x2? What do you mean by sigma of x1, x2? Hold. S2, capital S2. S2 means sum of product of roots taken two at a time. So there are four terms: x1, x2, x3, x4. So one pair is like x1, x2, x1, x2. The next one is x1, x3. The next one is x1, x4. The next one is x2, x3. The next one is x2, x4. The next one is x3, x4. Please don't worry if you are not able to write these things in detail. You will not need at this moment. Okay, please don't worry. But I'm just explaining what is this sigma. Okay, you can have this example like there are four persons: x1, x2, x3, x4. If I say count them in a pair, it could be x1, x2, x1, x3, x1, x4, x2, x3, x2, x4, x3, x4. Total 6 pairs will be there. I have written all of these 6 pairs, and then finally I am adding them all. So this will be what? C by A. Alright. Similarly, what about S3? S3, x1, x2, x2, x3, x4. So make a triplet: x1, x2, x3, x1, x2, x4, x1, x3, x4, and x2, x3, x4. Please observe. Okay. So it has to be what? x1, x2, x3 plus x1, x2, x4 plus x1, x3, x4 plus x2, x3, x4. And the last, S4. S4 is what? All the four taken at a time. So it is x1, x2, x3, x4. Alright, so this is the relation between roots and the coefficient. Now we don't need to memorize the right hand side part, we just need the left hand side part. That's it. You will automatically be comfortable with this segment later on, but at this moment nothing to worry. Okay, let's have a very basic, very simple, very beautiful question on this biquadratic equation, relation between the roots and coefficient of biquadratic equation. Let's have this question, guys. Everybody, yes, it says if this is the equation, this equation is having roots, its roots as alpha, beta, gamma and delta. Now I am labeling those roots as alpha, beta, gamma and delta. Please read the question. Then they're saying get me the value of alpha plus beta plus gamma plus delta. Can you see this is nothing but S1, roots taken one at a time, sum of roots taken one at a time. Four roots are there, one time add. Okay, so this is nothing but S1. And what about this alpha, beta, gamma, delta? Product taken 4 at a time. So this is nothing but S4. So guys, they are simply talking about what would be the value of S1 and S4 from this equation. Hurry up everybody, try this question quickly. Make it fast. Yes. So the biquadratic equation is written as x raised to power 4 minus 3x square plus 2 as what? 0. So I am rewriting this equation as x raised to power 4 plus 0 times x cube minus 3 times x square plus 0 times x plus 2 equals to 0 for a better understanding. Okay. So guys, with reference to the previous case, yes, let me go to that page. Yes, S1 is supposed to be minus B by A. S1 is supposed to be minus B by A. And what is B? Coefficient of x3. Okay. And S4 is supposed to be, yes, E by A. What is E? Constant term. Okay. So, what should be S1? Yes, it is minus times coefficient of x raised to power 4 minus 1, that is x power 3, upon coefficient of x power 4. So what is 4 minus 1? That is 3. So what is coefficient of x3? Here you can see coefficient of x3 is what? 0. So this is minus of 0 upon 1. Finally it comes out to be 0. Alright. Let's look at S4. Because it is 4, it has to be with plus. Okay. So now this is coefficient of x power 4 minus 4 in numerator and coefficient of x power 4. What is coefficient of x power 4 minus 4? That is constant term. What is constant term? That is 2. So it has to be 2 here. And coefficient of x power 4, that is what? 1. Coefficient of x power 4 is what? 1. So finally this comes out to be 2. So that's my answer. The first one, sum of roots taken one at a time is 0. Product of all the roots is what? 2 in this case. Alright. So we have seen the relation between the roots and coefficients of quadratic, cubic and biquadratic. The discussion we had with quadratic and cubic and biquadratic, that can be extended to a polynomial equation of n degree. The rule would be the same. If you say S3, that will be minus times what? Coefficient of x power n minus 3 by coefficient of x power n. Okay. So you can extend this discussion to any degree polynomial of any degree. Okay. So guys, in this lecture we have covered up what? The relation, the nature of roots of a quadratic equation with some certain condition when d is negative, when d is not a perfect square. All right. And thereafter we had the relation between roots and coefficients of cubic and biquadratic. So that's all for this lecture. In the next lecture we will go further with the next topic of quadratic equation. Till then, keep studying hard and practice more questions related to your relation between roots and coefficients and nature of roots with from your quadratic equation. Okay. Thank you so much guys. All the very best. Bye bye. Hello everyone, welcome to Crack Academy. My name is Antash Manocha and yes, we were discussing the chapter quadratic equation and this is the third lecture of your quadratic equation. Earlier, we have discussed the concept of polynomials, remainder theorem, factor theorem, nature of roots, relation between roots and coefficients for cubic, biquadratic and quadratic equations. Okay, so now in this lecture, we are going to start the topic transformation of equations. So guys, what are the transformations? We'll study with reference to the quadratic equation and all of these transformations are applicable to quadratic, cubic, biquadratic or any other degree equation. Okay, so guys, what are transformations? Say for example, you have a quadratic equation whose roots are alpha and beta. Now if I change the roots, if I say I need to form another equation whose roots are 2 alpha and 2 beta, 5 alpha and 5 beta, 10 alpha and 10 beta, alpha plus 1 and beta plus 1, alpha plus 3, beta plus 3, something like this. So change has to be uniform, that is change has to be uniform with each and every root. So if I do some changes, then what would be that equation with holding those particular roots? So we'll study this particular thing in the transformation of equations. Okay, so let's have a very basic example. I'll try to solve the example in a subjective way, then we'll see some shortcut techniques, we'll see some observation, and then thereafter we'll apply those observations in the subsequent questions. Okay, now let's have one very basic example. Let's see. Uh, let's say if ax square plus bx plus c is having the roots as alpha and beta as declared. Ax square plus bx plus c is equals to 0 is having roots as alpha and beta. Now they are saying form one quadratic equation. Form one equation whose roots are 2 alpha and 2 beta. As you can see, roots are being doubled. Roots are being doubled. So guys, how will you form any equation whose roots are 2 alpha and 2 beta? How will you form that equation? Yes, that is very easy. You will say x square minus sum of roots, the desired roots, into x plus product of roots. Alright. Observe, x square minus 2 times, this is alpha plus beta, and this is 4 times alpha into beta. Okay. Guys, here it has to be alpha plus beta, and here it has to be alpha into beta. But what is alpha plus beta? Yes, it is minus b by a. And what is alpha into beta? It is c by a. Now, we need to substitute these values here. Minus b by a and c by a. All okay? Now, what will you get? Yes. So, if you simply adjust these terms, what will you get? Yes, it comes out to be ax square plus 2bx plus 4 times c is equals to 0. So, that is the equation whose roots are 2 alpha and 2 beta. Observe, that is the equation whose roots are 2 alpha and 2 beta. Can we rewrite this equation as a x by 4 x by 2 whole square plus b x by 2 plus c? Can we rewrite this equation as a x by 2 whole square plus b x by 2 plus c? Observe what I am doing. I have just divided what this equation with 4. I have divided both sides with 4. So a x square by 4 is a x by 2 whole square. 2b x by 4 is b times x by 2. 4c by 4 is what c. Why I am doing this, you will get to know. Basically, I need to develop some trick for which I can directly write the desired equation. I don't need, next time I don't want to go through these analysis. Okay, so I need that technique. So observe, if this particular equation is having roots as alpha and beta, now you need to form another equation whose roots are 2 alpha and 2 beta. I'll give you one trick. Directly you can come from here to here, but with a transformation that you have to replace x with what? X by 2. Observe, if you simply change x with x by 2, directly you are getting this thing right now. So next time we are not going to do all these calculations, we can directly write the desired equation in one go. So we'll be learning those tricks. Okay, so that is known as transformation of equations. Okay guys, please note down, then we'll note down some trick. Okay, hurry up. Okay, let's move further. Now let's have a quick list of the types of transformation we are going to have. Yes, the first thing, if alpha and beta are the roots of ax square plus bx plus c equals to 0. If alpha and beta are the roots of ax square plus bx plus c equals to 0. Now they are saying then the equation with roots as, observe the first point, 2 alpha 2 beta. Then we need another equation whose roots are 2 alpha and 2 beta. Sounds similar with the previous question? Yes, we can directly rewrite the first equation to get the desired equation. But in this case, you will replace x with what? Yes, you will replace x with what? X by 2. Observe. So this will be the equation whose roots are 2 alpha and 2 beta. Okay. Sound similar with the previous case? Let's go for the next one. Yes, if I need to form another equation whose roots are alpha by 3 and beta by 3. Now observe, if I need to form another equation whose roots are alpha by 3 and beta by 3, what would be the direct trick. So guys, that direct trick is that simply replace x with 3x, x with 3x. I'll tell you how, just wait. X with 3x to get the desired equation. Okay. See, basically what is happening? The changes you are doing with the roots from alpha and beta to 2 alpha and 2 beta, the reverse operation you need to apply for x. You are multiplying the roots with 2. Now you will divide x with, you will replace x with x by. In the second case, you are dividing roots with 3. Okay. So now you need to replace x with 3x. You need to replace x with 3x. X is replaced with x by 2 in the first case. X is replaced with 3x in the next case. Roots are being divided by 3. Just change x with 3x. Let's go for the next one. If roots are added with 1, alpha and beta changes as alpha plus 1, beta plus 1. What would be the desired change here? Yes? Anyone? Yes, yes. In this case, you will change x with, go for the reverse operation, x minus 1, because you are adding 1 to the roots. So you will subtract 1 from x. Okay. So desired equation would be a times x minus 1 whole square plus b times x minus 1 plus c equals to 0. Okay. Let's go further with the next one. If alpha and beta are roots of the mean equation, then you need to form another equation whose roots are alpha minus 5 and beta minus 5. What would be that equation, guys? Yes, the changes with the roots is that we are subtracting 5. So in this case, you will do what? You will replace x with what? X plus 5 in the basic equation, the first equation. So you will get the desired equation as a times x plus 5 whole square plus b times x plus 5 plus c as what? 0. Okay. Next, if alpha and beta are roots of that equation, then you need to form another equation whose roots are 1 by alpha and 1 by beta. See, basically you are reciprocating the roots. In this case, you will reciprocate x as well. Okay, the same operation. Okay, so simply replace x with what? 1 by x. Okay, so final equation would be a times 1 by x whole square plus b times 1 by x plus c equals to 0. Okay, let's go for the next one. If roots are being raised to the power n, if we need to form another equation whose roots are alpha raised to power n and beta raised to power n, then what is the trick? Roots are being raised to the power n. In this case, you will replace x with what? Yes, x power 1 by n. Reverse operation. Do remember, reverse operation. So guys, in this case, yes, answer would be a times x power 1 by n whole square plus b times x power 1 by n plus c equals to 0. Okay, let's go for the next one. In the next case, yes, roots are alpha minus 3 by 4 and beta minus 3 by 4. What would be the main equation? What would be the equation whose roots are alpha minus 3 by 4 and beta minus 3 by 4? So in this case, alpha and beta are transformed as alpha minus 3 by 4, beta minus 3 by 4. So reverse operation, you are subtracting 3 and then dividing 4. So reverse operation would be like, we need to replace x with what? X into 4 and then yes plus 3. Reverse operation. See, alpha changed as alpha minus 3 by 4, subtracted 3 and then divided with 4. So reverse operation is multiply 4 first and then add 3. That is why 4x plus 3 is there. Okay, so quadratic equation would be 4x plus 3 whole square a times plus b times 4x plus 3 plus c equals to 0. Okay, let's go for the next one. In this case, roots are being changed as 2 alpha minus 1 and 2 beta minus 1. So alpha and beta are being twice and then we are subtracting 1. Reverse operation. So first with x, yes, first we'll add 1 x plus 1 and then we'll divide 2. Okay, reverse operation. So first we'll add 1, then we'll divide it with 2. Here 2 is being multiplied first and then 1 is subtracted. So subtraction reverse is addition, multiplication reverse is division. So main quadratic equation would be a times, yes, x plus 1 by 2 whole square plus b times x plus 1 by 2 plus c. That's it. So we have seen the variety where we can use the transformations. Okay, so alpha and beta are being modified uniformly. Then what would be the next equation whose roots are those modified roots? Okay, so please note down. Yes, if roots are 2 alpha and 2 beta, replace x with x by 2. If roots are alpha by 3 beta by 3, replace x with 3x. Alpha plus 1 beta plus 1, replace x with x minus 1. Alpha minus 5 beta minus 5, x with x plus 5. 1 upon alpha 1 upon beta, replace x with 1 by x. Okay, because reciprocal, reverse of reciprocal is reciprocal itself. Okay, so now let's apply this concept in some questions. Get ready. Hurry up guys. Let's read the first question. If alpha and beta are the roots of this particular equation, then the equation whose roots are 2 plus alpha and 2 plus beta. 2 plus alpha and 2 plus beta. Roots are being added with 2. So in this case, what will I do? Yes, I'll replace x with, yes, x minus 2. I'll replace x with what? X minus 2. So what would be the next new equation? A times x minus 2 whole square plus b times x minus 2 plus c. This has to be the answer. Okay. Now please observe, roots are being added with 2. Now we need to replace what? X with what? X minus 2. So they are saying this is given by, okay, they are writing the equation in different format. We need to mark true or false. So what will I do? I'll just open this here to get the desired equation. So a times x square plus 4 minus 4x plus b times x minus 2b plus c equals to 0. All right. So this comes out to be ax square, and with x you have minus 4a and plus b, the terms containing x, and the constant terms, it is 4a minus 2b plus c. Check. Yes, this statement seems to be true, exactly matching. Okay. So yeah, let's move further. Let's have this question. Now, as I told you, the transformation rules are applicable to equation of any degree. It is not restricted to your quadratic, it is applicable for cubic, biquadratic. Let's apply the concept of transformation in this particular cubic equation. Yes, let's read the question. Form a cubic equation whose roots are thrice to each of the roots of this particular equation. Thrice to that of this equation. I need to form a cubic equation, just form a cubic equation whose roots are, each of the roots are thrice to each root of this particular equation. Let's see. Say for example, this particular equation is having roots as alpha, beta and gamma. Now I need to form one called cubic equation whose roots are 3 alpha, 3 beta and 3 gamma. Okay, this must be the roots of that particular equation. So guys, as you can see, alpha, beta, gamma are being multiplied with 3. So your new equation can be directly written by replacing x with what? X by 3. That's it. So simply change x with what? X by 3. So it is x by 3 whole cube plus 2 times x by 3 whole square minus 4 times x by 3 plus 1. Okay. Now simply rearrange the terms. You will get x cube by 27 plus 2 times x square by 9 minus 4 times x by 3 plus 1 equals to 0. Let's perform the LCM or multiply both sides with 27. You will get what? X cube plus, yes, 6x square minus 36x plus 27 as what is 0. Okay, so this particular equation will be having roots as 3 alpha, 3 beta, 3 gamma. Alright. As I told you, this concept of transformation can be applied to the equation of any degree. Let's move further with the next one. Yes, it says if alpha, beta, gamma are roots of, very good question guys, are roots of this particular cubic equation, this small cubic equation, only only x cube term is there and constant term is there. Okay, then the equation whose roots are alpha square, beta square, gamma square, alpha, beta, gamma, just alpha, beta, gamma, yes, alpha, beta, gamma are roots of this equation. Now we need to form another equation whose roots are alpha square, beta square, gamma square. Yes guys, what should be the right approach? Roots are being squared. Okay, so alpha is replaced with alpha square, beta is being replaced with beta square, gamma is being replaced with gamma square. So what will I do? Final equation would be, yes, simply what to do? Replace x with what? What is the reverse operation of square? Just take under root. Okay, that's it. So simply replace x with what? Root x. So you will get root x whole cube plus 8 as what? 0. Now from this equation, just let me modify this equation a bit further. So it comes out to be x raised to power 3 by 2 as what? Minus 8. Now simply do squaring both sides. X raised to power 3 as what? Minus 8 square, and that is what? 64. So guys, my final equation comes out to be x cube minus 64 as what? 0. Let's see the option. X cube minus 64 as what? 0. Option D is there. Okay, so this is how we can apply the concept of transformation. Transformation will give you the idea how to trace that desired equation. In this case, if it was x power 3 by 2, so I did what? Squared both sides to get the desired cubic equation or the equation in cubic format. Okay, now let's move further guys. Let's have a tricky question. Okay, this is very beautiful question, and let's see. Yes, it says alpha and beta, just a minute, it says alpha and beta are the roots of a given equation. Okay, now then they are saying the equation ax square minus 4bx plus 16c is equals to 0 has the roots. This equation will have roots what? And they are saying, okay, we have transformed the equation. You know the rules of transformation. The transformation has been done. Can you guess the roots? Can you observe the transformation with the roots, with reference to the roots? That we need to check. Okay. Okay, let's see. So guys, the initial equation is ax square plus bx plus c equals to 0. Okay, I am writing the roots as alpha and beta. Observe the next equation. The next equation is somewhere like ax square minus 4bx plus 16c. So what is the trick? How will you identify what kind of transformation has been applied? So you need to check. They have replaced x with something as x. So we need to observe that operation. Okay. So what will I do? Let's see. It is ax square. It is ax square. It is bx. It is minus 4bx. It is c. It is 16c. So in these types of question, you will get the idea from that constant term. I'll tell you how. Here we have c. Here we have 16 times c. So first dissolve this 16. How will you dissolve this 16? So you will say, okay, I need to dissolve this 16 from the third term. Okay. So what will I do? Divide both sides with 16. Okay, let's divide both sides with 16. So ax square by 16 minus 4bx by 16 plus c is equals to 0 upon 16, that is 0. Okay. Now, can we rewrite this as ax by 4 whole square minus b x by 4 plus c. Now, in this phase, you can see up to some extent we can directly observe what kind of transformation has been applied. X by 4. But the middle term, the b, is making a problem. Here we have b, here we have minus b. Can you dissolve this minus? Observe. Can you dissolve this minus? Once that is done, everything is sorted. We can easily guess they are replacing x with what. So we'll apply the reverse operation to alpha and beta. That's it. Okay. So let me see how can we dissolve this minus sign. Yes, we can easily dissolve this minus sign by introducing minus x by 4 here, because we are going to we are taking care of this, plus d times minus x by 4 as here, plus c equals to 0. All okay? Now guys, our secondary equation comes out to be a minus x by 4 whole square plus b minus x by 4 plus c. Now we need to identify the roots of this equation. Now if I say from first equation to second equation, can you guess what is the replacement in x? Yes, we are replacing x with what? Check, check. Minus x by 4. Or better to say, we are replacing x with what? X upon minus 4. X upon minus 4. X upon minus 4. So we are dividing x with minus 4. So here roots that will be multiplied with, yes, dividing with minus 4. Now we'll we'll use the similar transformation, reverse of the transformation. X is being divided with minus 4. So in this case, roots alpha and beta, that has to be multiplied with minus 4. So roots will be minus 4 alpha and minus 4 beta. Okay, so yes, that option C is there. All right. So this is how we can play with the transformation. Transformation is very important. We have seen the example with cubic and quadratic. They can present many questions based on transformations. Okay. So sometimes it is like we need to address the equation, or sometimes we need to address the roots. The funda is same. If you're changing something with roots, so reverse operation has to be applied with x and vice versa. Okay. So that's all with the transformation, guys. So yes guys, after transformation, let's go to the next topic, and that topic is the concept of common roots. Concept of common roots in between two quadratic equations. Let's see the concept. What is the meaning by common root? See, you have the first quadratic equation, as you can see. The second one, the first one is having coefficients as a1, b1, c1. Second one is having coefficients as a2, b2 and c2. Both the equations have maximum two roots. The first is having, say, let's say, roots as alpha and beta. Second is having roots as gamma and delta. But what is the condition? What is the topic? That means common root. Common root says like the two roots, maybe both the roots common, or maybe they have a single common root. Initially they have the different roots. Okay, so in that case there is nothing like common root. But when we say common root, that means there can be a common root named as alpha. First one may have roots as alpha and beta. Second one may have roots as alpha and gamma. Or the first one may have roots as alpha and beta. The second one is having roots as alpha and beta, same. So we can have the two common roots, or we can have the one single common root. Okay, so now we'll be discussing the two cases when the two quadratic equation is having what? Two common roots or single common roots. So guys, when the two quadratic equation number 1 and equation number 2, both of them are having two common roots. I repeat my wording, that green case, the two common roots. That condition is very easy. That condition is very well justified. So that is very easy one. And when they are having a single common root, in that case we'll follow the process through some questions. So we'll go through that particular process. So we'll not list down that particular condition. So we have a condition only for the two common roots. Okay, let's see. So guys, yes, first point, condition for both the common roots in equation number 1 and equation number 2. That means that like the first one is having roots as alpha beta, second one is having roots as alpha and beta. So what is that condition? Let me highlight that condition first. See, that condition is a1 by a2 should be equals to b1 by b2 should be equals to c1 by c2. That's it. Please note it down. When the two quadratic equations are having both the roots common, so the ratio of the coefficients of x square should be equals to the ratio of the coefficient of x power 1, and that has to be equal to ratio of the coefficient of x power 0, or better to say constant term. It has to be equal to that only. So if this is justified, then the two equation will have both the roots common. Okay, now we'll see why it happens. Like we'll try to understand why it is happening like this, why the ratio is same. Okay, hold on. Let's have a very quick example to understand this thing. Now, if I say, just a minute. If I say, give me a quadratic equation whose roots are 1 and 2. tell me any particular quadratic equation whose roots are 1 and 2. Okay, so I want to write any particular quadratic equation whose roots are 1 and 2. So it can be x square minus 1 plus 2, that is 3x, 1 into 2, that is 2. So observe this quadratic equation. The roots of this particular equation are 1 and 2. Okay, please follow here. Next, can there only be a single equation whose roots are 1 and 2? No, there can be many. See, this is just one equation whose roots are 1 and 2. Let's have one more equation. Check. Can we say that the second equation is also having the roots as 1 and 2? Check, check, check. Observe, please observe. Yes, as you can see, I am just multiplying the first equation with the number 5. So each and every coefficient is multiplied with 5. So yes, you can have many equations whose roots are 1 and 2. So first and second, both of them are having the two common roots, both the roots common. So guys, what would be the generic condition? Like, as you can see here, the coefficient of x square is 1, here the coefficient of x square is 5. So 1 upon 5 should be equals to minus 3 by minus 15, should be equals to 2 by 10. Yes. Now if somebody says, yes, I can form another quadratic equation whose roots are 1 and 2, and he is saying 2x square minus 6x plus 4, 2x square minus 6x plus 4. As you can observe, yes, we are multiplying it with 2. So you can list as many as quadratic equations whose roots are 1 and 2, and between any two pair of equations, you will always have this condition. So that is why this condition is there. Okay, the coefficients must be proportional. The coefficients must be proportional. Alright guys. So now let's move further with the next case. Let's have the question. Yes, let's see this easy one. It says if the first equation and the second equation have both the roots common, both the common roots, the first one and the second one having the two common roots. So guys, directly I'm applying the condition, and thereafter we can easily get the value of lambda and mu. Yes, here the coefficient is 1 upon 3. That should be equals to minus 5 second upon mu. Okay, and that has to be equals to what? Lambda upon, yes, 12. All sorted? So if the two equations are having both the common roots, so this particular package must be justified. So now I'll solve this particular package. If I follow this particular equality in between these two terms, so I'll get the value of mu as just a simple cross multiplication. Mu comes out to be minus 15. And if I solve this one with this one, the simple cross multiplication, I'll get 12 by 3 as what? Lambda. So lambda comes out to be 4. So I get the values. Yes, what are the values? Mu comes out to be minus 15, and yes, lambda comes out to be, yes, 4. So that's it. If lambda is 4, mu is minus 15, the two equations will have both the common roots. Okay. Guys, once again, for two common roots, we have a condition. For single common root, the condition is a bit complicated, so we are not going to memorize that particular thing. We'll go through a process. We'll start through a process and we'll learn that process with some question. Okay, let's move to the next one. Let's have this simple question to understand the process of a single common root between the two equations, between two quadratic equations. Let's see the question. If the equations, first one and we are saying the second one, have a non-zero, highlighting this part, we'll use this one, common root. If these two equations have a non-zero common root, then the value of lambda, once again they are asking about some unknown constant in the coefficients, and they have given the data as the two equations are having a single common root, and also highlighting that part, a non-zero common root is there. Okay, what should be the value of lambda satisfying these three conditions? Let's see. Please follow the process that is the process I'm saying here. Okay, let's see. The first equation, x square plus 2x plus 3 lambda equals to 0. Second equation, 2x square plus 3x plus 5 lambda equals to 0. They are directly declaring that the two conditions are having a single common root. So guys, please follow. let x equals to alpha be that common root. That's it. Let x equals to alpha be that common root for which they are talking. If x equals to alpha is the common root, so you can directly put x as alpha here. Alpha x equals to alpha will justify the two equations. Let's proceed. If you put x as alpha here, so you will get alpha square plus 2 alpha plus 3 lambda as 0. Next you will get 2 alpha square plus 3 alpha plus 5 lambda should be 0. Now I'll solve these two equations, equation number 1, equation number, to get the value of alpha. Okay, to eliminate alpha, sorry. I'll solve these two equations to eliminate alpha. Now please follow the trick. What should I do? Here I am having alpha square one time, here I am having alpha square two times. So guys, the first thing is directly subtract, yes, just a minute, directly subtract twice of equation number 1 from equation number 2. Basically what I am doing, I am just comparing the coefficient of alpha square. I am just comparing the coefficient of alpha square. So what will I do? I'll multiply equation number 1 both side with 2. If I multiply both side of equation number 1 with 2, what will I get? 2 alpha square plus 4 alpha plus 6 lambda should be 0. Let me label this as equation number 3. I have multiplied both side of equation number 1 with 2. Why I am multiplying? Because as you can see, if I subtract it from equation number 2, so 2 alpha square and 2 alpha square will be adjusted. So I am following the process here. Equation number 2 minus equation number 3. Yes, what will be the final conclusion? 2 alpha square minus alpha square nullified. 3 alpha minus 4 alpha minus alpha, 5 lambda minus 6 lambda minus lambda should be 0. So from here I am getting the value of alpha as what? Minus lambda. Okay, hold. Next, just like I have eliminated alpha square from the two equations by comparing the coefficients, now is the time to eliminate alpha by comparing the coefficients. Now is the time to eliminate alpha by comparing the coefficients. So what should be the process, guys? Everybody, here the coefficient of alpha is 2, here the coefficient of alpha is 3. So I'll multiply equation number 1 with 3, equation number 2 with 2. Listen once again, I'll multiply equation number 1 with 3, I'll multiply equation number 1 with 3, I'll get 3 alpha square plus 6 alpha plus 9 lambda should be 0. And I'll multiply equation number 2 with 2, so I'll get 4 alpha square plus 6 alpha plus 10 lambda equals to 0. Now this is my equation number 4, this is my equation number 5. All okay? So guys, basically I'm just eliminating alpha square and alpha. Okay, just like we used to have linear equations, we used to eliminate the value of xy. Okay, we used to eliminate the value of xy from two linear equation up to your 10th standard. The same process is here. So now if I do one thing like equation number 4 minus equation number 5, what will be the final conclusion? Now as you can see, 6 alpha will be adjusted. So 3 alpha square minus 4 alpha square minus alpha square, 9 lambda minus 10 lambda minus lambda as what? 0. So from here once again alpha square comes out to be, yes, alpha square comes out to be minus lambda. So what is it? What is the final conclusion? Alpha comes out to be minus lambda, alpha square is minus lambda. That's it. Now I'll go for the final step. Guys, alpha square is minus lambda, alpha is also minus lambda. From these two equations, let me label this as equation number 6 and equation number 7. Now from equation number 6 and 7, can we eliminate the value of alpha? Yes, from 6 I am getting the value of alpha as minus lambda. Put it here. So you will get minus lambda whole square as what? Minus lambda. Just simply simplify this. Lambda square should be equals to minus lambda. Lambda square plus lambda should be equals to 0. So guys, lambda can be, yes, this will give me what? Lambda can be 0 or lambda can be minus 1. Fine. So final conclusion comes out to be lambda can have the value as 0, lambda can be the value as minus 1. Okay, easy one. Please follow the process once again. The two equation first thing that I am declaring, let alpha be the common root. Now I am rewriting the two equation with x as alpha. The next is one by one I'll try to eliminate the value of alpha and alpha square. So finally alpha comes out to be this, alpha square comes out to be this. So from those two equations I'll eliminate alpha. So finally we are getting the package in terms of lambda only. So finally lambda is having two values, one is 0 and second is -1. Now what should be the answer? Guys, if I pick lambda as 0, if I pick lambda as 0, if I pick lambda as 0 here, lambda as 0. Please observe the common roots between the two equations will be 0 because lambda is what, minus alpha na. So the common root is alpha. So lambda 0, if I choose lambda as 0, lambda is 0, so my common root will be a 0, 1. So but they are saying a non-zero common root. So this should not be the right answer. This should be the right answer. So lambda comes out to be -1. Once again, please understand the last fact. If lambda is 0, guys, if lambda is 0, put lambda is 0. So alpha comes out to be 0. What is alpha? The common root. But common root has to be non-zero. So that is why lambda 0 has been neglected. So what should be the value of lambda? It has to be -1. Easy one. So this is the process we are going to apply in the case of single common root. Okay. Let's see. Let's go to some more examples. Okay, let's look at this one. This is also very easy. Now this time we have three equations. First, second and third. Please observe. If every pair of the equations have a non-zero common root, then the sum of the three common roots is. If every pair of equation is having a non-zero common root, then the sum of three common roots is. Okay. So let's say the first equation. The first equation is x square plus px plus qr. Next equation, x square plus qx plus pr. Third equation, x square plus rx plus pq. Please read the demand of the question. What is the data? It simply says the three equations have a non-zero common root pairwise. So pairwise non-zero common root. Let's say the first equation is having roots as, please check, alpha and beta. Now let me make a common root between the first and second as beta. So second is having roots as beta and gamma. That makes sense. So let me make the common root between second and third as gamma. So gamma and alpha should be the two roots of third equation. See, first and second having common root beta. Second and third is having common root as gamma. First and third have common root as alpha. Okay, so we are going through the given data. Let us list down this. Now, what is the demand? Then the sum of three common roots. Three common roots. The first common root in between 1 and 2 is alpha. Second is beta. Third is gamma, pairwise. So basically, what is the demand? They are interested in what? They are saying, tell me the value of alpha plus beta plus gamma. That is the question mark. So how should I solve? Yes, I'll not go into the concept of single common root just like the previous one, two common root, nothing like this. I'll simply apply what? Sum of roots. That will justify the purpose. Check. We need the value of alpha plus beta plus gamma. Okay. So now, what is alpha plus beta from first equation? It is minus p. What is beta plus gamma from second equation? It is minus q. What is gamma plus alpha? Minus r. Now simply add them all. So you will get what? 2 times of alpha plus beta plus gamma as what? Minus p minus q minus r. So guys, what is the value of? What is the value of alpha plus beta plus gamma? Yes, it comes out to be minus half of p plus q plus r. Very easy one. Okay. So we are going as per the demand. The question is saying don't go for the condition of common root. Don't eliminate alpha. No. Simply they are saying pairwise we are having some common root. So I am applying those conditions. Simply we are getting the sum alpha plus beta plus gamma. Okay guys. Let's go to the next one. Hurry up, hurry up, hurry up. Let's see the variety in more detail. Yes, it's a tricky one. This was the question that has been asked in JEE Mains and JEE Advanced, and please observe this question, very tricky. If ABC belongs to real number, okay, one thing is this, and the equation, the first one and the second one have a common root, then A ratio B ratio C, then A ratio B ratio C. Hurry up, hurry up. How will you try? Yes, the two equations have a common root. As per the given data, they are declaring they have a common root, single common root. So what would be the ratio of A? What would be the ratio A ratio B ratio C? What would be the value of this A ratio? You can look at the option 1 ratio 1 ratio 1, 1 2 3, 3 2 1, 2 3 1. Okay. Before we go to the category of single common root, just like we had this thing in last to last question, we'll put x as alpha, alpha square, we'll eliminate alpha, alpha square, and then we'll justify the thing. But here we have three unknown things. In the previous case, we only had one single unknown thing, that is lambda, that has been eliminated. But here, if I pick common root as alpha, so from these two equations, I'll not be able to get the value of exact value of A, B, and C. Okay, because there are three unknown things as per the given data. Now, what should I do? Just simply look at the second equation first. This is very beautiful. Just look at the second equation. The second equation is, okay, I am taking it here, x square plus 2x plus 3. Please observe the nature of roots. Please observe the nature of roots of second equation. What is D? D is b square minus 4ac. Yes, D comes out to be negative. Guys, when D is negative, hold on, when D is negative, roots are non-real. When D is negative, roots are non-real. One thing, and the coefficients are real. D negative, roots are non-real, and the coefficients are real. What kind of the roots are there for second equation? Yes, the second equation will have roots of the type p plus iota q and p minus iota q. Iota is under root of minus 1. Yes, roots must occur in a conjugate pair. If p plus iota q is there, then p minus iota q have to be there. If p minus iota q is there, then p plus iota q is also there. Because if D is negative, coefficients are real, roots appear in conjugate pair. Okay, this was the point that we have understood in nature of roots. Okay, so now let's see. If somebody came and say, okay guys, the two equations have this one common. If someone is saying, and someone came and say, let's have p plus iota q common to first and second equation. Let's have p plus iota q common. Let's have this p plus iota q. Okay, now let's look at the first equation. So guys, now reread that property once again from nature of root. The first equation is having coefficients as real. The first equation is having coefficient as a real number. And the first equation is having one of the root as p plus iota q. The first equation is having one of the root as p plus iota q. Yes, yes, yes. Then the other root must be, if coefficients are real, one root is non-real, then other root should be its conjugate pair. It has to be p minus iota q. That is the trick in this question. Okay, it has to be p minus iota q. Why so? Because if p plus iota q is one of the root, then its conjugate part has to be there, because coefficients are real. Okay, coefficients are real. So p minus iota q would be the second root of this equation. If yellow one is the root, then the green one has to be the second root. Or if someone says, let's say common root is p minus iota q. So guys, read the statement first once again. Coefficients are real. One root is p minus iota q, then the other has to be p plus iota q. Got it? So ultimately, that is the hidden trick in this question. They are declaring that the two equations have a single common root, but actually the two equations are having both the roots common. Two equations are having both common roots. So if these two equations are having the two common roots, then a by 1 has to be equals to what? B by 2. This has to be equal to C by 3. So what should be the ratio of A ratio B ratio C? What should be the value of A ratio B ratio C? Yes, it is there as option B. So this was the tricky question in JEE. Okay, please note down. Very, very beautiful question. Indirectly, it was 2 common root. Actually, they were giving yes single common root. Okay. Okay, let's move to the next concept, guys. Next one more question from JEE Mains. Okay, let's see this question. JEE Main 2021. Let's see. Let lambda not equal to 0 be in real number. If alpha and beta are the roots of this equation and alpha and gamma are roots of the next equation, then the value of something beta gamma by lambda. Okay, let's see. I think the two quadratic equations, first one and the second one, they are having only a single common root named as alpha, right now. So what should be the approach? Guys, the two equations are having a single common root named as alpha. Okay, so do we need to eliminate alpha and alpha square, and thereafter we'll get the value of lambda, just like we had in last to last question? Yes. Okay, one thing is this. Okay, once I get the value of lambda from there, then I need to address lambda here. Thereafter we need to get the value of beta and gamma. That means we are supposed to get the exact value of the other roots except from common root. Okay, product of those two other roots. Okay, so what should be the process? Like in the previous question, eliminating alpha and alpha square was a lengthy one. But wait, I'll follow the process as per the demand, as per the question. See, it says the first quadratic equation is having roots as alpha and beta. What can be a generic conclusion from this data? First quadratic equation is having roots as alpha and beta. Simply I'm writing alpha plus beta as what? Yes, sum of root would be b minus b by a. So it has to be what? 1. Sum of root is minus b by a. And what should be the product of roots? Alpha into beta. Yes, it comes out to be 2 lambda. Okay, so this is my equation number 1. This is my equation number 2. Let's see. Alpha and gamma are the roots of the next equation. What is alpha plus gamma? It is minus b by a. Its minus b by a is 10 by 3. And what is product of alpha into gamma? Alpha into gamma, it is 27 lambda by 3. That comes out to be 9 lambda. So this is my data number 3, data number 4. Okay. See, I'm not going to eliminate alpha. See, JEE Mains is there now. They are not going to go for the lengthy approach. Okay. So please use a smarter approach. So I have written some product for the two equations. Now, can we solve these 4 equations? Listen, can we solve these 4 equations to get the value of alpha, beta, gamma, gamma and lambda? 4 equations, 4 unknown quantities. A situation is a win-win situation. Why so? Because 4 equations, 4 unknown quantities, equal number of equations, equal number of unknown data is there. So we can easily eliminate alpha, beta, gamma data from alpha, beta, gamma and lambda from these 4 equations. That's it. So I'll simply eliminate the values of the variables that is needed. So now what is the process? Let's see. First equation and third equation. If I subtract them, so guys, this beta minus gamma is what? 1 minus 10 by 3. That comes out to be, yes, minus 7 by 3. Let me label this as equation number 5. Second and fourth, if I divide them, so guys, gamma by beta, 4 by second. I repeat, 4th by second. Gamma by beta, it comes out to be, yes, 9 by 2. Equation number 6. Once again, see, first minus third, alpha eliminated, beta minus gamma comes out to be minus 7 by 3. 1 minus 10 by 3 is minus 7 by 3. Fourth by second is gamma by beta. It comes out to be 9 lambda by 2 lambda. Lambda eliminated. alpha eliminated. So gamma by beta comes out to be 9 by 2. Now from this particular equation, let me do some more calculation. What will I do? Yes, I'll get the value of gamma here. Gamma comes out to be 9 beta by 2. Now I'll put this value in equation number 5. So yes, let's go here. Put in 5. What is the value of gamma? 9 beta by 2. 9 beta by 2. So beta minus 9 beta by 2 is what? Minus 7 by 3. So the left hand side comes out to be minus 7 times beta by 2, and here it is minus 7 by 3. So guys, beta comes out to be, yes, simply 2 by 3. One data is eliminated. One term is eliminated. Beta, I got the value of beta. Okay, guys, if beta is 2 by 3, if beta is 2 by 3, now look at equation number 1. Now from equation number 1, what would be the value of alpha? Alpha is 1 minus beta. So alpha comes out to be 1 minus 2 by 3. 1 minus 2 by 3. So guys, alpha comes out to be 1 by 3. Alpha is done, beta is done. Okay, alpha sorted, beta sorted. Now knock at equation number 2. From equation number 2, yes, product of alpha into beta is 2 lambda. So 2 lambda is what? Alpha into beta. It comes out to be 2 by 3 into 1 by 3. So guys, lambda comes out to be 1 by 9. Sorted. Alpha done, beta done, lambda done. But what else is there? Gamma. So from equation number 3, gamma comes out to be 10 by 3 minus alpha. What is alpha? 1 by 3. So 10 by 3 minus 1 by 3 is 9 by 3, 9 by 3 is 3. So gamma comes out to be 3. So all done. Very easy to eliminate the unknown data, to get the unknown data from the 4 equation. I am not going to apply the concept like we did in the single common root. I am not following that particular process, because the question is not saying go to the lengthy method. Question is saying simply write the equations, eliminate the unknown data. That's it. Okay. So now, yes, what is the final answer? Beta is what? 2 by 3. Gamma is 3 upon lambda is 1 by 9. So finally it comes out to be, yes, 18 as the final answer. Okay, very easy. So this is how we are going to apply the concepts of single common root, two common roots into quadratic equations. Okay guys. Okay, so now after this, let's go further with the next topic. Yes, the next is identities. Let's see the concept of identity. What do we mean by identity? So before dealing with the identities, specifically quadratic identities, what kind of quadratic identities are there? Let's understand the difference between an equation and an identity. Let's see, let's note down the difference between an equation and an identity. Okay guys, we have seen the word equation, we have seen the word identity. What kind of difference is there? See, when we say equation, equations may have some root, may have some solution, may have some zeros. Okay, equation may have some solution, some roots. When we say identity, identities are not like the equations. Identities are valid for any value of that particular value. But if we talk about the equations, equation may or may not hold true for some specific value of the variable. Okay, let's see. For example, we have this x square minus 7x plus 12. That seems to be your quadratic equation. Max to max, it can have two roots, and we can easily find the roots. This is having two roots because discriminant seems to be positive. 49 minus 48, it is positive. But if we talk about one quadratic equation like this, check the value of discriminant. 1 minus 4, that is negative. So this time it is not valid for any real number. This is true for two real values, this is not true for any real value. Okay, now let's look at some equation. Let's look at some identity. X plus 1 whole square minus 1 plus x square minus 2x. Read this. It seems like algebraic identity. X plus 1 whole square is x square plus 1 square plus 2 into 1 into x, like a plus b whole square. But I have written everything to the one side. You can go to the right hand side. No issue with that. But if you closely look at this particular data, this is valid for all values of x. The first one is true for two values. The next one is not true for any value. The third one is true for all the values of variable. You can also rewrite this as this way. Still, the game is same. This is valid for all values of x. If you put x as 1, LHS is equals to RHS. X as 2, in third case, LHS is equals to RHS. X is 10, LHS will be equals to RHS. So what is the difference between the third and the first? The third one is known as identity. Algebraic identity, just like that. That is why the word is there, identity. Trigonometric identity. Trigonometric identity. Sin square theta plus cos square theta is what 1. This is valid for all the values of theta, 30, 40, 60, 90, 0. But if we have something like this, sine of theta as what 1 by 2. So this is valid only for some specific angle, just like 60 degree, 30 degrees. Okay, so that is trigonometric equation. This is trigonometric identity. Understood the difference between the equation and identity? So please note it down. I am writing the difference, please. Yes, equations true for may or may not be true for some value, but identities are valid for all x. So please write it down. Equations may or may not be true. Please everybody, equations may or may not be true for some specific values. Whereas identities are valid. Identities are valid for all the values of the given variable. I repeat, equations may or may not be true for some specific set of values, whereas identities are true for all the values of given value. So clear cut difference. This is true for all x belongs to real number. This is may or may not be true for some x. Okay, that is the difference between an equation and an identity. Now, why we are going to study here with quadratic equation? Hold on, I'll tell you. Let's see some quadratic identity. Let's have the data in this way. Say for example, if I say what would be the possible number of roots of this equation? What would be the possible values of x for which LHS is equals to RHS? Tell me, what would be the possible values? Yes, we know a quadratic equation is true for max to max 2 values. Okay, max to max 2 real values of x. Why maximum 2 real values? Because quadratic is having degree 2, so it is maximum, the maximum number of roots would be 2 only. Okay, why maximum? Because a quadratic may not have real roots, so it is not true for any real value. Quadratic may have 2 equal roots, so it is true for only a single value. Okay, and quadratic is not true for quadratic is true for 2 values. That's it, maximum 2 roots. Okay, now the next thing, if somebody come and say if this data is true, check what I'm writing. If this is true for, first thing, all x belongs to real number, or this is true for more than 2 values of x. Please read this data. If somebody came and say, guys, I am having a quadratic equation which is valid for more than 2 values of x. I am having a quadratic equation which is valid for more than 2 values of x. So we'll say, no, that is not true. Na? On our planet, like we have, okay, degree 2, maximum roots are 2. But somebody came and say, I am having a quadratic equation which is true for more than 2 values of x. Or somebody came and say, I am having a quadratic equation which is true for all values of x, all real values. So would that data be fine? Yes, that can be true. That will be true if this is true for all values of x. Then a x square, please note it down, a x square plus bx plus c equals to 0 is an identity in X. And what do you mean by identity in X? That means this is true for all X belongs to real number. Okay. Such that, and what would be the condition? A should be equals to B, should be equals to C, and everything should be equals to 0. Please read in this flow. Yes, they are simply saying this equation is true. Either they can say for all X belongs to real number, or they can say true for more than two values of X. In that case, that equation will be treated as what? Identity in X. And what would be the condition that it is treating it is acting as an identity? Yes, all the coefficients should be 0. If all the coefficients are 0, then pick any X, LHS is equals to RHS. That's it. Okay, guys, that is the concept of identity, specifically quadratic identity. You can extend this discussion up to cubic as well. Just a minute, before we have a question, let me write one more remark. Okay, if somebody says if ax cube plus bx square plus cx plus d is true for more than, guys, cubic maximum 3 roots, more than 3 real values of x, or true for all x belongs to real number, then once again this will no more be like your cubic equation. Okay, this will be what? Then ax cube plus bx square plus cx plus d equals to 0 is acting as an identity in X, such that what should be the condition? A should be 0, B should be 0, C should be 0, and D should be 0. All the coefficients must be 0 if this is acting as an identity in X. Pick any value of X. If A, B, C are 0, then LHS is equals to RHS. Okay, that is the concept behind identity. Now let's have a very beautiful, very basic question to understand any identity of any type. This is quadratic identity, this is cubic identity. Yes. Let's have this question, guys. Read the data. If this particular thing be an identity in X, now they can use any wording. They may say this is an identity in X, or in your question they can declare this is identity in X, or they can declare true for all X belongs to real number, or they can say this is true for more than 2 values of X. Okay, see, I'm writing like they can use this wording, they can use this wording, they can use this wording. Ultimately the concept is same. This is acting as an identity, and if it is acting as an identity, then what should be the final condition? The coefficient of X square should be 0. At the same time the coefficient of X should be 0, and the same time the constant term should be 0. Now if you follow the first one, you will get as plus minus 1. If you follow the next one, you will get a as 1. If you follow the third one, just let me solve this a bit. A square minus, yes, this is 3a minus a plus 3. So you will get a minus 1 and a minus 3 as the good factors. So a comes out to be 1, or a comes out to be 3. So what is the final conclusion? A can be this, a can be this, a can be this, but we are interested in what? This and this and this. So what is that common value of A for which all the 3 things are justified? Yes, that common value of A is A should be equals to 1. So guys, if I put small a as 1, that particular thing, that particular equation is acting as an identity, not like the equation, quadratic equation. and that will be true for all x, that will be valid for all x, more than two values of x. Okay, so that is the idea behind the identity. Okay, so that's all for this lecture, guys. In this lecture we have covered up the topic transformation, the concept of common roots, and also the idea behind the identity, quadratic identity, cubic identity. So in the next lecture we will be starting with the graphs of quadratic equation. Graph is very important. So in the next lecture we will be starting further with the graph of quadratic equations. Okay guys, so till then, thank you so much, bye bye, all the very best, keep studying hard and practice more questions from quadratic equation. Make a rule that you are going to practice minimum of 25 questions per day, 25 questions from mathematics. Okay, so that you can get comfortable with the subject, you will have more clarity. That's it. Okay guys, thank you so much, see you in the next class, bye bye.